Okay, guys, we want to start Chapter 11 today. This is our video for 11.1 areas of parallelograms and triangles. I want to talk about parallelograms first, not just because it's listed first, but I think that'll help knock out some other formulas that we have coming. Please remember now from here to the end of the school, everything that we've studied this year may pop up. Anything could happen. Anything can pop up in finding these areas and volumes. This is sort of a culmination of a lot of the skills that we've learned this year and a lot of things that we've learned about relationships of shapes. So be on your guard. Also, there's going to be quite a few formulas to remember in Chapter 11 and Chapter 12. And no, I will not let you have a formula card. You need to know these. You're honor students, and that's part of the challenge of being in honors. You need to know these. I think that if you will write them down every time you have a problem that you're using the formula in, it will help you tremendously in memorizing. But I think these first three we're going to talk about are some that you've had before, and you're not going to be that worried about memorizing. Okay, so let's jump in and get started. Let's just briefly talk about what area is. Let's put a square up here. How about? Okay, if I have a square, or a rectangle for that matter, but I tried to make that a square, and I want to know the area of that square, then I'm trying to find out how many little bitty perfect square tiles it would take me to fill that particular region up. So I would start with whatever unit that I was told to use, if it was inches, centimeters, feet, kilometers, whatever my unit is, I'm going to take a square with dimensions of that square 1 inch by 1 inch or 1 kilometer by 1 kilometer. And I'm going to see how many of those unit squares it takes to cover my space without any overlapping. That's what area is, trying to find out how much it takes to cover a region. Sometimes, like this one, it may turn out to be nice and pretty. But sometimes you may have some drawings that may not come out so evenly when you put them they may not come out so even when you, there we go, use your tiles. See, these don't have nice sharp corners. So you may have sometimes a region that doesn't come out exactly even, and that's okay. There's nothing wrong with that. So in other words, you're not going to freak out if we get fractions, okay? That's a nice long way of saying that. All right. I'm probably going to need quite a bit of workspace. So let me save that. All right, I want to talk about parallelograms first of all. Now remember, darlings, when we talked about parallelograms back before Christmas, we learned all those rules about, the consecutive interiors and the opposite angles and the opposite sides and all those good, interesting things. With parallelograms, we know that both pairs of opposite sides are parallel, like so. And they're also congruent to each other. So the left and the right are parallel to each other. The top and the bottom are parallel to each other. The left and the right are equal to each other. The top and the bottom are equal to each other. If I want to find the area of a parallelogram, I'm going to pick one of the sides as the base. B equals base. And I'm going to multiply that base by its height. Its height. Okay, now when I say its height, it means I just don't go grab a height from somewhere. It's got to be that particular base's height. So in the case of the drawing that I drew for you, if this is my base, then the height is going to be the perpendicular distance from the opposite side to the line that contains the base. So that's going to be my height. The perpendicular distance from opposite side to line containing the base. Because as we're going to see in a minute, sometimes we're going to use an outside height, and that's okay. It's still the distance between those two segments that I'm trying to find the height of, the length of, okay? So B is our base, and H is our height, our perpendicular height. So please note that the base and the height are going to always be perpendicular to each other. Remember that we had some special parallelograms when we studied parallelograms before Christmas, and one of those specials was the rectangle, and another was the square. Okay? Well, both of these are going to play off of our same formula, that the area is the base times the height. The area is the base times the height. Sometimes, and most of us in elementary school, learn the rectangle is the length times the width, and it is, and that's the same thing, and there's nothing wrong with that, and that's wonderful. I am not going to use the words length times width because L is going to be a symbol in another formula that we have coming up. So I want to reserve the use of the L until I get to my pyramid so I can use L for slant height. So I'm going to be using base times height with my formula, okay? So I'm just going to remember that my rectangle is just like the parallelogram, a base times a height, which is one of the dimensions times the other dimension in that particular rectangle. So a base times a height, okay? But with a square, I'm still having the base times the height, but in my lovely little square, my base and my height are the same. And we usually refer to them as a side. So an area of a square is the side times itself. We're still, again, looking at a base and a perpendicular to the base, but I've got a side times itself. So really, just by looking at the parallelogram, we really have three formulas here. Well, this doesn't want to cooperate with me here. Been having trouble with my iPad today anyway. Okay, so this is my formula for my area of my parallelogram, my formula for the area of my rectangle, and then my formula for my area of my square. Okay, let's look at some examples. I'm going to look at example 1. I'm not going to look at all these examples with you, and I'm not going to carry them all the way through to completion, but I'm going to look at several because I want you to be prepared to do these. We're asked to find the perimeter and the area. Now, we talked about the area being the region that's covered. In the case of example 1, the blue region. But remember, the perimeter contains the word rim. Do you remember that from probably in elementary school? That means the outside edges. You add all those outside edges together. So in the case of the diagram that we have here, this figure, we're going to add the length of AB, the length of BC, the length of DC, and the length of AD together. Well, we know that opposite sides of a parallelogram are congruent, or that they are equal in measure. So if DC is 4, then AB must be 4. And if AD is 10, then DC must be 10. In that case, we're going to have 2 10s plus the 2 4s to find our perimeter. So 20 plus 8. So we're going to have 28 inches, and yes, we need to label it. We need to label it correctly. We don't need to worry about asking if that's going to count off points. We're just going to do it right, correct? Okay, so we're going to see that 28 inches is the distance around my parallelogram. And I need to know the area. So my area, I need a base and a height. Now, guys, look at this. Let me see, let's do this in a different color. This picture is suggesting to me what they want me to use for the base and the height. Do you see that? It looks like, see, they've got this height in here. And what is that a height to? It is a height to BC. So this is strongly suggesting, I can't talk. They are strongly suggesting that the base be side BC and that the height be length DE. And that's what we want to stick with. So my base I found a while ago is going to be 10. And the height they've given me to be 5. So I see that I've got 50, and we're still with inches, square inches for area. Because it would take 50 little inch squares to fill in and cover all that blue space. So I always label perimeter in straight inches, and I always label my area in square inches. Okay, now something I wanted to note up here. Okay, yeah. Up here, notice where it said parallelogram ABCD. That tells me that that's the order that the vertices should follow. So if I was not given a picture and I was just given this piece of information and I had to draw my own parallelogram, I would draw a parallelogram and then I would have to put A somewhere, but I would either have to go clockwise or counterclockwise around that diagram because the order of the letters is the order of the vertices. Okay, I could have said A, B, C, D, but I have to go in a specific order. I can't just jump around. So don't forget that. I know we talked about that last semester for a little bit, but I don't want you to forget that now. Okay? Excuse me. I'm getting kind of hoarse. Okay. So let's look down here. Do you notice that we're having, and we had it in the one we just looked at as well, we're having some little right triangles formed in there. So right triangle rules are going to be extremely important as we work these out. We're going to apply the Pythagorean theorem a lot. We're going to use 40, 60, 90, 30, 60, 90 rules a lot. We're going to use 45, 45, 90 rule a lot. We're going to use SOHCAHTOA a lot. We're going to use just regular trig definitions, you know, that sine is opposite over hypotenuse and other things as well. So we're going to be looking through a lot of situations here, and we're going to have to recall a lot on these. Okay, on number 1H, finding the perimeter, I know easily how to figure out this problem. I know that I can use that opposite sides are congruent. So if my right side is 17, my left side is 17. If the top is 21, the bottom is 21. So to find that perimeter, I have two 21s, and I'm going to add to that two 17s. So I'm going to have 42 plus 34 is 76 centimeters. I label it. I don't square it because it's not area. Now to find the area, I'm going to use my base times my height. Again, write that formula. And let's see what I know. I know that my base is 21. By writing the formula and by plugging in what I know and leaving blank what I don't know, it kind of helps me get a focus. If the base is 21, the height is what I don't know, so it tells me the next thing I have to do is find the height. The height is the little red dotted line in here. Well, how do I find that? It's the side of a right triangle. Remember that the hypotenuse always goes on the side by itself. So 17 is the hypotenuse squared. That equals to the 8 squared plus the h squared. And I'm going to solve for h. And whatever I get for h, then I'm going to plug it into my formula, multiply my numbers together, and my area will be given in square centimeters. Okay? Now look at there's a little hairline difference in 1B, and I want to point it out to you. In B, I've still got to find the perimeter. So my perimeter is, okay, the bottom's 23, the top is 23, but I don't know the left or the right. Again, I have another little pretty right triangle. So I'm going to use the Pythagorean theorem to find this particular length, but this time it's my hypotenuse that is missing. So I'm going to have that my c squared equals 24 squared plus 7 squared. And I'm going to solve for c. And that's going to be those two particular lengths. I think it works out to be 25 if I have my Pythagorean triples correct. Okay, so for my perimeter, I'm going to have two 23s plus two 25s. It's going to be a 46 plus 50. So I'm going to get 96 feet for the perimeter. Now the area, again, is the base times the height. The base is going to be the 23. Now look at this. The base is not 30. It's not this whole line. It's the base. It's a piece of the parallelogram that I'm using. So my base is 23. My height is this perpendicular height. It's not the 25, it's the 24. So I'm going to multiply 23 times 24, and whatever I get is going to be an answer that is in square feet. Okay, look at old example 2 down here. To find these other measures, I know if the bottom is 15, my top is 15. And I know if EH is 8.5, FG is 8.5. I've got to find the height. Well, guys, look, I've got a right triangle, and it's a 45, 45, 90 right triangle. The hypotenuse is 8.5. So if I know the hypotenuse is 8.5, I know that I take a leg and multiply by root 2 to get the hypotenuse. So dividing 8.5 by root 2 will give me this length as well as this length. Okay, and you can see they solved it in their calculator and found that the height is about 6. So it's approximately 6. Therefore, they were able to find the area. Look at 2B. It's using 30, 60, 90 rules. Let's remember those. Remember that the leg across from the short leg, I'm going to draw that a little bit bigger. This is what they have down there. Okay, I know that this is my short leg because it's across from the 30. It's given to be 12. When I have the short leg, I double it to get the hypotenuse, which is always across from the right angle. And I take that short leg and multiply it by the square root of 3 to get the long leg. So I have to use those old rules to help me work these. And I'll use them a lot. Okay, let's shift over to triangles now. Where does a triangle come from anyway? Or how can you construct it or come up with one? Well, look at what I've got right up here. Whoops, not right up here. right up here. I've got a parallelogram. And you see how that parallelogram has been cut in half? When a parallelogram is cut in half, I form two triangles. If I want to find the area of one triangle, I'm really dealing with half of a parallelogram. So that's what I've got going with a triangle. The parallelogram and the triangle are cousins. Okay? At least they are with area formulas. So I'm still going to find a base times the height. And my base and my height are going to be perpendicular always. But then I'm going to divide that product by 2 because I don't have a parallelogram anymore. I have half of it. So the area of my triangle is 1/2 base times height, or as some folks like to say, it's the base times the height divided by 2. They're the same thing, aren't they? So either way that you want to refer to that particular formula, you are welcome to. So let's look at some examples with the triangle. Looking at 3A at the top. We've got to find the perimeter again and the area. So let's focus on our perimeter first. Okay, so my perimeter, I've got to add up the 3 sides. So I have a side that's 41. I have a side that's 19. And this other side, I do not know. But I've got a right triangle, and it happens to be the hypotenuse of the right triangle. So I can find that missing hypotenuse by using Pythagorean. So once I find C, I can plug it in over here and add these together. And whatever that total is, I will have the total number of inches that's in my perimeter. Now let's find the area. The area is 1/2 the base times the height. Let's see what we know and what we don't know. The base. Well, look at this, guys. They've given us a height in here of 30. See that 30 right there? That's the height from one vertex to the other side. So that's the height from this side to this side. Well, what is this side length in the triangle? It's 19. So the base that we're using in this triangle is the 19. And the height of the triangle, in other words, the perpendicular distance from the side to that line containing that opposite vertex, is given to be 30. So I'd multiply those together, and my answer will be given in square inches. Okay? Just giving you some hints through here. Look at 3B. Do you see how you have a right triangle again? So to find this side that I'm about to outline in blue, see that? I'm going to use the Pythagorean theorem again, but this time I know the hypotenuse. So when I find B, it's going to be that little segment right there. Also notice that if that outside triangle is a right triangle, then my blue region is a right triangle as well. Once I find B, then I can square it and square the 29, and that will give me what we'll call C squared. Then I'll be able to have all my sides, and I can find my perimeter and my area. So be on guard, be on your lookout. Be careful with your arithmetic. Notice on this one, if you missed B, you're going to miss C. So be very careful. Show your work so you can get partial credit if you can. Label your units correctly. Area in this one would be in square centimeters. But I love, 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 you know, the problems, how much I love the problems when the algebra and the geometry come together. They're the best. The height of a triangle is 5 centimeters more than the base. The area is 52. Find the base and the height. All right, we were given the height in terms of the base. So we've got to let B represent the base of the triangle. Therefore, the height is going to be b plus 5, since it's 5 centimeters more. When you write down that formula, like I've asked you to, it's easy to go ahead and plug everything in that you know. And whether you get stuck or not, you're able to get to a point where you get a pretty good bite into that problem just by plugging in and then seeing how you can find the piece that you need to plug in. For instance, right now, if I just had this much, I'd be at a dead end. But going back to my formula, or to my, sorry, not my formula, going back to my problem, it tells me that the area is 52. So I want to use that piece of information. 52 is 1/2 b plus 5. Okay, this is what these guys did right here. Then at that point, they got rid of the fraction by multiplying both sides by 2. And then they distributed the b, and look what happened. They came up with a quadratic. Oh, whoa. Got a quadratic equation. If the quadratic equation factors, that's the easiest thing you can deal with, so you will factor it. If it doesn't factor, you guys are too far along in mathematics now to complain and to not know that you're going to have to use the quadratic formula. If you have trouble remembering the quadratic formula, there are songs and jingles and all sorts of things all over the internet, all sorts of things on YouTube to help you remember that. So find something that's going to help you remember your quadratic formula. Okay? Even if you have the quadratic formula in your calculator, it will give you the answers if you have whole numbers, and it will give you the answers if you have decimals. But if you're asked for simplest radical form, or if one of your choices on the SAT or ACT is in simplest radical form, then you don't have a leg to stand on. So you're going to have to go back and do it the old way. Your calculator is to assist you. It's not to replace your brain function, okay? So you need to make sure that you know the formula. If you use your calculator to help you with it from time to time, that doesn't bother me so much, but you better make sure you know it and know how to apply it so that you won't miss some little easy problem like that on a standardized test. Okay, let's see, what else do we have down here that I wanted to show you before we go on. I'm going to emphasize this again on 4A. Remember, when you are using area, and we've got a parallelogram here, don't we? I'm going to have my area is base times height because I got a parallelogram. My base is going to be the 8. Okay? The base does not continue just because the side had to continue to get a perpendicular. Okay? The base is going to always be one full side of one of the parallelogram. The extension will never be included in base times height. The extension is to help you find the height itself. Okay? So that's something that I want to point out to you strongly, because as I said, I've seen these mistakes made by really good students like you guys before, and I want to make sure we head them off. Okay, let's piggyback on what I just said. Look at number 5. If I'm going to find the area of number 5, the area is 1/2 the base times the height. The base is the 5. It is not 20. And the height is the 8. Okay, so be very, very careful on ones like those. Look at 4. There's a 45-45-90 rule, 30-60-90 rule. Pythagorean theorem all over the place here. So I want you to be alert to those as you work on these. All right, let's look at number 22, I guess. 21, 22. I think I'll pick 22. Let's say I want to find the area here. It's a parallelogram. So I'm going to have a base times a height. And I see that the height that they're using is this height. So 22 must be the base. So I've got to find my height. I don't have enough information to use the Pythagorean theorem. I don't have a 30, 60, 90. I don't have a 45, 45, 90. I'm going to have to use SOHCAHTOA. Okay? So I've got my focus angle here of 40 degrees. With respect to 40, I know its opposite side. I'm looking for its adjacent side. So I'm going to have to use the tangent trigonometric function. The tangent of 40 degrees is opposite over adjacent. And I'm going to have to solve for x to find out what my height is. And then once I find that, I will plug it in. Okay? So that's one that we had not seen yet that they slipped in on us. But I see some down through here that they've got that you're going to be needing. One final note before we turn you loose on your homework assignment is number 37, find the area of ABC graphed at the right. Now, just because it's graphed, that does not change the fact that your formula is the area is the base times the height. You may not agree with me, and that's perfectly fine if you want to do this a different way. But I'm looking at AC as my base. For some reason, it just looks more like a base to me. So I'm going to find AC as my base. And how am I going to do that? How am I going to find the distance between 2 points on a Cartesian plane? I'm going to use the distance formula, okay? I'm going to find this ordered pair and this ordered pair. And remember what your distance formula is. Okay, so you're going to have to find your distance formula to find the distance on your base. Then you're going to have to find the height. Well, this takes us way back to the first semester. Remember, if we have a line, which we do with AC, and a point not on the line, how do we find the distance? And it's got to be the perpendicular distance from a point not on a line to a line. Okay, that goes back to first semester. Well, it may have been, I think it was first semester. So we've got to remember things like this that we've had before, that we haven't seen in a while, to find and answer questions. You are more than capable of doing that. As I look at this problem, I didn't assign number 35, but look at this Heron's formula. Have any of you seen the Heron's formula before? As it says, it relates the lengths of the sides of a triangle to the area. You will see this and use this when you get into pre-calc next year. So for you go-getters, you want to make sure you write that down. And remember, Heron's formula is an alternative to finding the area of a triangle. So you may want to put that down and remember that, especially in your last project that you're working on to get ready for things that you remember to take with you when you leave our class very soon. Okay, I think that's enough discussion of 11.1 to give you a nice hefty push into the work. So your job now is going to be to complete the assigned problems. I'll be available in the room if you have any questions.